Okay guys, so in this video we are going to talk about exploits, and I'm going to touch on something that I thought was very well illustrated in a article I read just the other day that virtually walked through some of the risk that you can find with people overusing a lot of JavaScript or having a lot of different packages, and basically a way that a hacker can compromise your system through something called a cross-site scripting attack. Now I know, before you start clicking to another video or anything like that, this is not going to be one of those, oh, I am going to go to one of your comment sections and try to put in some HTML and get some alert or script into your web page through you not basically validating your code on the server. This is going to be a little bit fancier than that, hopefully. So a traditional XSS attack goes something like that. Basically, a attacker can input information to your system, you store it on your server, you don't escape it, there's HTML in the text, and then you serve up that content to another user, and voila, they stole that user's cookie or directed them. They basically take control of the web page. Now, there are a few ways of doing this, and I'm going to walk you through an approach that was illustrated in this article that I thought was really it sparks a very nice thought. Oh, look at that Docker update, but we're going to ignore that for now. So let's just walk through the code first. So here we have our server, and basically this little simple application of ours is just an Express server that serves up two static pages, an index HTML file at the root and a /logging page. That's all it virtually does. And so we have a welcome HTML file and the actual index.html file itself. And we are depending on a little bit of JavaScript here. We use Webpack to virtually grab the main.js file you saw here and create a bundle.js file that you can see here that is then being required by our page. This is just a very simple demo application. Let's take a look at it. So here we are, our little logging page, right? So the idea here basically is that you say that just any user starts typing out some information here, and then we click login, nothing happens. Click login again, nothing happens. Well, what's going on here? So if we look at the sidebar here with our network request, we can see that the expected result here is that you click login and you actually get logged in and you go to the next page, right? But what's actually happening is that this script that we have added to our page is doing something very differently. So here we have some weird network request that goes to some localhost port 3001 with some weird text here. Don't really know what's going on there. So let's examine this for a moment. Let's have a look here. So here I have my entry point and my main.js file, and now you can imagine, for the sake of argument, that this is just one of your files in your Webpack configuration that you use in order to add some JavaScript to your page. And you're simply requiring this little script here. Now, let's walk through this script. So this is a basic attempt at creating our own. Basically, it's just a script, a malicious script that steals some data once it's being loaded onto the page. And let's just walk through it. So the thing we're doing here is that we are adding an event listener for the submit event onto the page, which basically is going to run whenever somebody's trying to submit a form of some sort. We prevent the default behavior. We grab the forms object, convert that to an array, and then we do some reduce with a function of a. And if you're wondering why I have a single variable name for my functions, that is basically because I could have done this through minification, but when you're writing a malicious script of some sort, you want to be secure, create security through obscurity, which basically means that you don't want to have any semantics in your code. You want your code to look as complicated as humanly possible, so that if somebody starts looking into your code, they don't really know what's going on, because what you're actually doing is that you're trying to hide your malicious code in somebody else's project, and so it helps you if they don't understand what's actually happening. So basically what's happening is that we're doing a reduce here, we're getting some value d, and then we do use b2a, which is basically going to take this value d here and convert it into a base64 encoded string, and then we do a fetch request to this external server with that information. And if we go and look at what's happening on my evil little server here, as you can see, what's actually happening is that we're getting that string we saw earlier, and then we are logging out my username and my password. So what's going on there? No, this one is what we want to look at. Let's look at the evil server. So the evil server is just basically a single node express server that has set access control allow origin or the course header to any, so that whoever wants to access my server this endpoint from JavaScript from whatever domain can do so, and then it grabs the query, the Q query, like the string that we saw earlier. It converts this base64 encoded string into a UTF string and simply logs that out. So what this script is actually doing, if we follow the logic here, so it grabs all the forms on the page and it gets all the children of the form, which are going to be the input fields. It reduces over those as well. And so for each input field, it's just going to check if the name of that input field is equal to username. Then we add the username and separate it with a semicolon. If the name is equal to password, we add that too, and we separate it with a semicolon. And then we just return the string whenever we're done. Easy peasy. So instead of me as the creator of this web page, I wanted to log in my user, and now I have a script here that is basically compromising my user's information. This private information is now being sent off to somebody else. So this is a first attempt at creating such a malicious script. But let's go one further. Let's go to, because you're going to tell me that, all right, Frederick, I see what you're saying. These scripts are, you can build a script like this, but yeah, there are probably static analysis tools, right? That I'm going to see if somebody's trying to reference like a script that I don't really know what's going on there. I'm going to see that it's referencing a username, or I'm going to look at the code and I'm going to understand what's happening. Or I have tools that are specifically looking for any code that I don't own that is using something like fetch or anything like that. Okay, let's make another iteration of this script. So this is basically the same script with a few modifications. The biggest modification is this C function here. And the C function takes in a string. It splits the string, so it gets an array of letters. It maps over these letters, and then it uses this function. String from char code, which is going to take the ASCII character code and convert that number into a string. So we get the string's character code and add 1 to it, and then we join everything and we get back the full string. So what we can do with that is that we can now write code that doesn't actually use the name of whatever we want. We can actually just give it this weird string here. This is actually, when it runs through the C function here, it's going to return the string username. And the same thing goes here. This is going to return password. So what's powerful about this is that I can actually now express everything that I want to happen without ever using any keywords that your script might be looking for, like your tool might be looking for, or you yourself are looking for. So I don't ever have to write the word username ever, and I can do much fancier stuff than this. And I want you to take away from this, this is true for almost anything. So look at our B function now that we saw earlier. It's just referencing these two variables. So I'm not looking for name is equal to username or password, which would be something that a static analysis tool could possibly catch, or you yourself might be looking for. So you can't search for something like that anymore. Let's go down here and look at this really weird thing that's happening here. Should you recognize it? Well, this is equal to this. It's the exact same thing. What's happening here is that I go to the window object, I use the bracket annotation and my C function. This weird word here, when it's run through my C function, it actually converts this weird string to the word fetch, and then I run that function with localhost 3001 query equal to q, as we saw earlier, but you wouldn't recognize it, and you can't search for it. I think it's pretty cool. This is a way that you can obscure away almost everything in the code that you're writing, so that nobody can actually just look at it and see that, oh, he or she is trying to do these and these things. I mean, I can even remove event listeners. I can do anything. And something like that. And all of a sudden I have an add event listener on the page without you ever actually being able to figure that out from simply reading the code. So this is the next iteration where I obscure away a lot of the semantics of the code. Let's go even further. Let's load script number 3. And let's build that. Because somebody's going to tell me that, oh, well, Frederick, if it's kind of silly because here I am not being like, if I deploy this application to production and my users can't log in, obviously I'm going to notice that something's wrong. And yes, to be fair, you are right. If this is something that would have been noticed immediately. But let's try this. So I click, and as we saw earlier, nothing happens. And then I click again. Ta-da! I just came into the page that I expected. Alright, that's odd. Let's try that again. Let's go back. Let's do something like that. Click login, and it works on the first try. Let's try it again. Alright, let's just refresh it to be really sure that everything is working. Oh, it keeps on working. So what happened there? If we look at our evil server, we actually stole the password and the username, but what's going on? Why is it working? Let's look at it. So we can create a script that will only actually run a single time. So here we use local storage, where we set a variable, or rather we check at local storage for an R variable, and if that R variable is set to true, then we will simply return. So the script gets loaded to the page. The user clicks the first time, it doesn't work. No harm, the user thinks that they just made a mistake, they click again, and now everything is working, but we still stole their stuff. And all we have to do is to make sure that we basically check if when the submission is actually happening. If we already sent the information, we simply return because we don't want to send it twice. And whenever we do send it, we just set that R variable to true, so we know that we will never run this script twice. So now the user will never know, they will never report anything, and you, even if you as the developer or who is trying to debug something like this, will probably never get a report of this from a user unless they somehow figure out that it was your site that compromised their system. This is very unlikely, but now we have a way of running this script a single time. Pretty cool, right? And you say, yeah, somebody could, in theory, clear local storage and do it again, but I don't think so. I think this is fairly inclusive, and we can go even further than this. Let's have a look at this one. Only run once at random, because let's say, for the sake of argument, that all right, for some reason you are just figuring out that something's going on here. Something is not right. If I introduce a bit of randomness, like this, let's say that I do the same check. I will only run the script a single time, but I will also only run it at a random sequence, which means that sometimes it's going to work on the first try, and sometimes it's not. And it will only steal the password once, and then it will work forever. Or rather, the script will never block the user from submitting the form again. So with a bit of randomness, this all becomes extremely difficult for somebody to debug. Like you as the developer, I can just speak from experience, I would never find this. If I didn't know that this code was here, I would never find this in production. And then somebody's going to tell me, well, Frederick, yeah, you're just a regular developer. Maybe we have some type of professional security analysis type of person, a security chief of something, that checks these things and are really good. And they're checking all the logs and they're checking the network and they even in this very obscure case when it's only happening a single time for a single user, they're gonna catch it. All right, let's go one further. Let's say that the script only gets loaded to the page on off hours. When I know as the hacker and creator of the script, I know that no one in the right that your security chief, he's probably not going to work in the middle of the night. So my script is going to just bootstrap to the page and run at random only once on times I know that are not work hours. All of a sudden 95%, like a really like just increased my chances of this script living in your application by I can be pretty sure that this is now going to fly under the radar on your security chief as well, even if they're looking at the network traffic. You might argue that this will be caught, and yeah, if you have a really rigorous, really professional, really zealously, I don't know, passionate security master of a security chief, maybe they'll find it in the logs somewhere. But still, worth thinking about. And finally, let's look at this final iteration. Let's only run this script once at random when your security chief is sleeping and never in a development environment. So what we can do is that we can add common words like a local host, dev, QA, or staging. For those of you who are not working as professional developers, these are very common words in testing environments. And localhost, as we see, this is just me running my stuff on my own computer. So if none of this stuff, we basically loop through all of these, and then we check the location of where we are in the browser. And if we find this word in the URL, then we will simply not do anything, because we only want to run the script once at random when everybody is asleep, or your staff, your security chief is sleeping, and we only want to run it in production. All of a sudden, this makes it even more difficult for somebody to actually figure out that something malicious is going on. So hopefully you're starting to understand what you can actually do with just a little bit of JavaScript and how much damage you can do. Now, let's do the final thing, because somebody's going to tell me that, oh yeah, Frederick, this is so obvious. How would I check all my scripts. I would never load some random person script or some third-party script that I don't use. But let's remember that a lot of the time you have a lot of metrics, you have like Google Analytics and different ad companies and stuff like that. Don't forget that ad companies, if you have an ad company script on your page, they might be loading in all kinds of stuff that you're not aware of. So you can't really check the network and see that and be very confident that this is not supposed to be there. And this final one is the one that really made it clear for me. Let's say, for the sake of argument, that you have this awesome library, saydog, or _saydog, which is this awesome, cool library that everybody uses. Let's add that in. Cool. So let's go to the page. And all saydog does is that it logs out the word dog with an underline. That's all it does. So I try to log in, click login, nothing happens. What is going on? Well, the evil server is there again, and I'm logging something out to the evil server. And as we can see on the network request, I'm actually doing the same thing as we did in the first script. So what's going on there? Well, now you're going to tell me that, all right, Frederick, you probably have some malicious package here. And you're absolutely right. But what I want you to think about here is that you are not directly, the beauty of this is that I'm now depending on a library somebody wrote for me, and although that library has a very good reputation and it has a lot of stars and it's really awesome and popular, that library is depending on something that is a little bit insecure. And here is the script. Do you see the problem? So my dependencies are malicious. And it can go even further down than that. My dependencies could be compromised. The chain can just go on and on and on. All it takes is a single malicious package to be included in any of these packages. All of the stuff that you see here, every single node module that you have has this vulnerability, or the possibility of this type of vulnerability. If it's running on the server, if it's running on the client, doesn't really matter, it will come into it. This is a possibility for every single package that you use. All it takes is for somebody to add some malicious code in a single package, and get that on npm and get somebody to depend on it. And if you then depend on that other package, you'll get that malicious code with you. That's how it works. So I hope that this little demo of mine has illustrated partly how a very basic malicious script that steals passwords and credentials and stuff like that could work. And also I hope I made you realize that you should be a little bit careful when you're depending on packages and you shouldn't just add libraries willy-nilly. You make sure that if you're adding dependencies to your project, you are depending on packages that have a good reputation and that have a lot of contributors and, secure and well established and so forth. And even if you do that, you have to just kind of cross your fingers and hope that the people who are maintaining that package that you are using are they themselves making sure that they are not including anything malicious, because if they are, that's going to come to your web page as well. I hope you have a great day.